All right. Good morning, Doctor. Good morning, Aina, and good morning, everyone that can be listening to us on YouTube. I'm David Vargas, part of the Habitat Marte mission number 83, virtually happening, and it's international. And I am in charge of the Engineering Center. We'll be running through what the Engineering Center will have in Habitat Marte when we're established on Mars. This is a bit of an overview on the different topics that we'll be discussing on the presentation. A little bit more on each of these as we go on. More of the overview and the references to finalize. Now, to start things off, let's talk about the internal design of the Engineering Center. This is a general layout of the 3 levels that we'll be having on the Engineering Center. So top level, level 3, is the Research and Development Center, followed by the living quarters straight in the middle. And the bottom level, or the first floor, is going to be the Technical Servicing Bay. The reason the living quarters are exactly in the middle is so efficiency is conserved when it comes to the engineers or the astronauts working on this center to be able to access both the research and the technical areas with relative ease. Now, for the level 3, the Research and Development Center, here on your right or maybe left, you have a layout of the floor planning and what each area of that respective floor is expected to have. For the Research and Development Center, for instance, we have a general storage area, many monitoring centers, experimental floor, a testing bay, and a 3D printing area for experimental materials in 3D printing. Now, the main objective of this area is to provide an environment to conduct various engineering tests, analysis, and experimentation. There will be a minimum of 1 person working in this station at all times, and there is a max capacity of personnel in this area of 6. Now, for living quarters, the second level or the second floor, the main objective of this area is to provide a personal area for local workforce to rest, dine, and suffice general necessities, as well as offer general entertainment. There will be a minimum of 1 person in this level, and there is a maximum capacity of 8 for people in this area. Now, the general floor planning is comprised of a personal storage area. There's a dining station. There's an entertainment hall, the sleeping chambers, a bathroom area, and a farm/produce segment. Rather small farming area, but just something so that crew members can sustain themselves without having to interact with most of the overall station. And last, but certainly not least, the Technical Servicing Bay, the first floor of the Engineering Center. The floor layout looks something like this. There will be a repair station, a monitor segment, a vehicle bay for a manned piloted vehicle, and a second vehicle bay for rovers, for our little robotic helpers on the ground. There will be a 3D printing area and a general storage area. Now, the main objective of this first floor is to provide a high-paced maintenance and production area to monitor overall station engineering needs and to service on-site vehicles. There will be a minimum of 2 persons per work area here in this station, in this level, and there is a maximum of 8 people on this level. Overall, there should be only 8 analog crew members living and working in this center as a whole. So, apply technologies to make anything and everything work in this engineering center. So we start out with general installation systems. These are systems that should be present on all centers in the station. We have life support, thermal controls, general storage and production, and general farming, okay? So for life support, for instance, in the engineering center, and is advised to be taken into consideration to all the centers, we'll have an environmental control and life support system modeling the one used in the ISS. This life support system is able to recycle water and oxygen from the station's own little enclosed atmosphere or environment. And obviously a thermal control module following the standards used from the one in the ISS to regulate temperature within the station. Now, there will be a general standard for smart storage systems and designated storage areas in the engineering center with production mainly 3D printed and the general farming sections should be medium-sized vertical farms, and these segments should be able to produce some sort of greenhouse effect to aid plant growth. Now, for specific engineering things in the engineering center, we have the Research and Development Center. Now, a general listing of the machines and technologies that we'll be using here are listed here on the right, and I'll be reading through them. We have material testing equipment, 3D printers, a vacuum chamber, the chemical testing equipment, metrology instruments, and bear with me, metrology is simply a fancy word for saying measurement instruments, to take measurements, computer and dedicated servers, electronics testing equipment, which is, I know, borderlining on what Ina's working on, but a little bit of electronics here, mechanical doesn't hurt, and a decontamination chamber. These are all things that will be present and should be present in the Research and Development Center. Now, technologies and equipment for the living quarters. So for entertainment, I was thinking more astronauts should be exposed to a bit of a virtual environment for virtual games, be it virtual games, virtual interactions with family and friends back on Earth, or virtual training sessions, all can be held in this environment in living quarters. And for general entertainment, movies, video games, TV, you name it, astronauts will be able to have it in the living quarters. And for general necessities, we'll be using this latest iteration of the ISS toilet, which is much more comfortable than the suction device that was priorly used on station, exercising equipment, and a general all-purpose cooking station for the astronauts in the living quarters of the engineering center. Now, the technical servicing bay, it not has the usual maintenance found on technical car service suppliers here on Earth, and 3D printers and general storage racks. It will also house the exploration and servicing vehicles for the station. Now, when I say exploration fleet, there is maybe one big astronaut occupiable vehicle on station and a number of 3 to 4 helping servicing rovers on station. The servicing fleet will help on construction and overall surveillance of the exterior of the station, as well as exploration. And the main astronaut vehicle here on the top right will assist astronauts in having to travel long distances and maybe explore or set up outposts elsewhere. The main purpose of the technical servicing bay is to be able to provide maintenance and repairs to these vehicles. Another area of importance for the technical servicing bay is to be able to maintain and or produce types of drills that will help us on different mining expeditions to exploit resources on the surface and subsurface of Mars. We'll get into details on the types of materials later on that we'll be extracting and can be obtained from Mars. And this is the slide where we talk about what we can obtain from Mars. Now, on-site materials available for us on Mars, be it surface or subsurface, include but are not limited to water ice, iron, carbon, there's titanium, there's nickel, there's aluminum, sulfur, chlorine, calcium, silicon dioxide, and clay-like minerals in abundance on Mars, surface and subsurface, and can all be attainable via drill and processing. And general resources that will be transported on the initial instances of the mission from Earth is oxygen, liquid water, and an assortment of polymers just to get the 3D printing process started and going. Now, management in the engineering center. This is the organizational structure, a general hierarchy and pyramid of how instruction is to be passed along the members of the engineering center, starting off with a facility chief and a chain of command leading from the lead engineer. There's a safety supervisor and a lead researcher. Now, the lead engineer and the lead researcher will have 2 assistants, which are for the engineer, auxiliary technicians, and for the researcher, research aides. This is a total of 8 people overall working at all times in the engineering center, by the way. Now, these are the profiles for the astronauts and their general duties. Think of these as the requirements to work here. Now, the age requirements vary depending on the position. The chief facility engineer is to be the oldest or has the interval allowing the oldest age of being able to work in this position. The educational level is at least a PhD with 10 years of experience in the preferred fields of study, aerospace, mechanical, and electrical. The prerequisites to be able to attain this position is to have an approved astronaut training program back on Earth. And the general tasks for the facility chief is the management of the engineering center and its major programs, projects throughout the duration of the mission cycle. Now, the safety supervisor is to also have a minimum educational level of a PhD, 6 years of experience working in the city in the aerospace, mechanical, electrical, or systems engineering areas. The prerequisites are the same for all positions in the station, is to have an approved astronaut training program back on Earth. And the general task for safety is to supervise the technical servicing and research and development programs for safety protocols, assure overall facility safety, and best work practices. Think of it as a safety officer in a plant environment. That is the overall job of the safety supervisor in the engineering center. Now, we have the lead engineer and the lead researcher. The age scale, if you notice on the top right, varies. They can be a bit younger than the facility chief. Now, their respective educational levels are the same, at least a PhD, and with 8 years of experience in their respective fields each. For the lead engineer, the preferred fields of study are aerospace, mechanical, and electrical. And the general task for the lead engineer is the management of the servicing division. Servicing division are the 3 people that will be working on the first floor, the technical bay. Provide technical support to other personnel and lead facility-wide engineering checkups. And for the lead researcher, which has the preferred fields of study being aerospace, mechanical, electrical, and physics, the general tasks comprising the lead researcher are the management of the research and development division. So this is the 3 people, including himself, that will be working on the research and development center on the 3rd floor of the engineering center. And his task is to provide expert insight into investigations and participate/supervise laboratory work. Okay. Now, for the lowest ranking job in the engineering center, which is 2 of each, is the auxiliary technician and research aide. And don't be confused, just because it's the lowest ranking or job on the hierarchy list does not mean that they do not lack the educational and the experience, the educational background and the experience to be there. Because to be an auxiliary engineer or technician and an aid scientist or a researcher, you need at least 5 to 6 years of work experience and a minimum of a master's degree in a preferred field of study mentioned here, being aerospace, mechanical, electrical, systems, or physics. Okay. Now, for the auxiliary technicians or engineers, the general tasks comprise of the following: the assistance in the overall engineering duties within the technical bay or elsewhere in the station, and to perform routine maintenance on vehicle fleets. This is the fleets mentioned prior on exploration and our helper robots or servicing fleet. For research aides, the tasks are a bit different. They are tasked with assisting the development of investigation and research performed in the laboratory. They need to compile data and analyze it, as well as perform several testing types and experimentations. Now, the astronaut training program. Let's keep in mind, each role within the engineering center is distinct, but the technical programs and the managerial programs should be general and should expand through all the personnel in the engineering center. So technical programs for the engineers working on site should be a general laboratory equipment usage program. So they are well versed in dealing with all types of equipment in the research and development laboratory. There should be a rover maintenance guidelines and instructions program so that engineers that arrive on site, especially the ones that are going to work on the engineering center, are familiarized with the systems of a rover and what are their parts and how to fix them, and the general instructions on how to proceed with this. There should be a technical program for systems engineering and its principal guidelines and principles as well, because overall in the station, we will be working with several systems, expanding all fields of engineering. So a bit of systems engineering knowledge for all engineers on site is more than necessary and very helpful. And overall, a general station safety sweep training. Now, general station safety sweep is a sort of checkup done station-wide, run by the lead engineer to make sure that all engineering needs in the station are met and or maintained. Okay, managerial programs, basically programs that teach you how to lead and be a leader. So we got a project management training, and for the auxiliary technicians and the research aides, or anyone who wants to later on in the mission life cycle take on a leading role, we have the acting division lead training exercises. This is basically to promote expansion and promotion within the environment, the work environment in the station, allowing lower ranking personnel to take on leading roles in the station, to lead their own projects and divisions in the future as a form of training for future promotion. And last, but certainly not least, we have the ELV drivers program and the ULV drivers program. Now, the ELV is the Exploration Land Vehicle Driver and Training License. This is the big vehicle mentioned prior that astronauts will be able to drive to go out and explore the Martian surface, and the Unmanned Land Vehicle Driver and Training Licenses. Now, unmanned land vehicles is the maybe 1 or 2 rovers that will be manned by people in the station and are robotic in a sense. Now, these are general YouTube videos to train astronauts in the engineering center. We have several videos on the principles and guidelines of systems engineering and rover systems, and managerial videos to help promote a sense of project management and project awareness. We have a list of project management videos for the astronauts. Now, the resources needed for 1 week is a standard and should not fluctuate with time, because if we do experience fluctuations in the needs of resources in the station for 1 week, then major adjustments into production and resource acquisition should be made. Okay, so what we're looking at here is a general standard, and I will move on. Now, guidelines to be provided to the engineering center and overall engineering work throughout the entire facility. There's a lot of text from now on because there's guidelines and protocols for everything, so bear with me. I will read through. The general guidelines for the engineering center personnel comprise of the following. They should perform daily routines and scheduled activities, retain a healthy occupation and standard. They should always perform redundancy checks for any engineering process, consult with a fellow crew member when faced with odd results or a task that is not easily completed, uphold the highest ethical standards for engineering, refrain from utilizing obscene language outside of the living quarters. Now, I know this might sound silly and you might not make of it much, but ensuring a professional environment in the workplace ensures that there is always a serious tone to the work that's being done in the workstations. Now, when the astronauts are in the living quarters, they can refer to each other as please and relax, but in the workplace, we should refrain from using obscene language. Now, the other guidelines is to promote integrity and perseverance in the workplace, promote creative thinking and team problem solving, never skip leisure or rest time unless there is an emergency. This is very important to be able to maintain astronauts' psychological and emotional well-being. They should never skip their rest times and their times to be able to entertain themselves with their preferred entertainment systems. And last but not least, do not postpone or retract from meeting deadlines and objectives. So we can always stay on track and mission objectives are never missed or postponed. Now, protocols. I know there is meant to be several slides on this, but all protocols in my case are compiled into one slide with the specific protocols for the facility and all its segments, okay? So a general guideline for emergency engineering protocol is to be set and is to be followed throughout the entire engineering center. Protocols for the research and development center, the third floor of the entire complex, is data collection protocols, data analysis protocols, and experiment handling protocols for the distinct experiments that will be held on the research and development area. Now, the living quarter protocols expand from anywhere to hygiene, dining and farming, and leisure protocols to the specific times and the activities that can be held by astronauts in the living quarters. And the technical servicing bay has its own set of protocols that span from in-house daily, which is basically just the daily scheduled and prerequisite activities that are to be held in the technical servicing bay. We have the station sweep protocol, which is the safety check station-wide, led by the lead engineer. We have the maintenance bay protocols and the production and inventory protocol for handling 3D printers, the scheduling of 3D printed parts, and the storage and cataloging of these 3D printed assemblies. Now, spin-offs and technologies that happen and can occur on station to implement on Earth. We have this set of immediately identifiable spin-offs and technologies that can be outputted towards Earth, and they are the following. We can develop an effective methodology towards robot-based construction work. This is because currently on Earth, we have not yet experimented with swarm-like robot building. Bear in mind, the servicing fleet that I'm proposing, or that Habitat Mars is proposing for the space station on Mars, is around 2 to 3 rovers that are specifically modified and designed for construction work. And this is yet to be fully visualized and realized on Earth. So a proper methodology developed on Mars can greatly influence future construction work on Earth. We have efficient floor layout and ergonomic practices for limited workspaces. Bear in mind, all these levels mentioned are around 8 meters in diameter. So it's a rather small area for an engineering environment. If most engineers are accustomed to a plant-based or industry-based perspective to engineering, so an 8-meter diameter is rather small for most engineers. So we will have to develop a mindset and an efficient work layout, floor layout, to meet the ergonomic needs of the astronauts on station. There will be experimental 3D printing with Mars-based materials. Mars-based materials is a fancy word for the Martian clay. So we haven't ever 3D printed with Martian clay. So this is going to be something that can be translated to Earth. Another thing that can be derived or outputted from work on the mission on Mars is study on the psychological effects being housed in the very same place you work on for extended periods of time. I would like to expand on this for further explanation. So the engineers on the engineering center have the capability of sleeping, living, and working in the same environment for an extended periods of time. And that mix between my living space and a workspace is something that we're currently experiencing with COVID, because many workplaces switched to online. So many people that used to go to a plant or to an office to do their work mixed their work life into their living quarters and their life. And this is something that the astronauts will, pardon me, I did not mean to switch the slide. This is something that astronauts will be facing every day for the rest of their mission duration, okay? They will have to be able to emotionally deal with the mixture of their work environment directly into their living quarters and living life and living environment. Now, the last two technologies and outputs that can be derived from the mission and applied to Earth are novel rover modifications and implementations derived from on-site needs. Of course, we can always engineer, design, and plan concepts here on Earth for what the rovers will be doing on Mars, but once we get to Mars and once we actually deal with the situations there, new ideas, new inventions, new modifications to rover designs will be developed, and these can be then transferred back to Earth. And last but certainly not least, something that can be applied to Earth is an entirely new perspective on living on Mars, because as of yet, every human being on Earth is imagining life on Mars, but only people who get to live there will actually be able to recount the true perspective of what life on Mars really is. Okay, so now let's move on to the guidelines to be applied to life on Earth. So general guidelines to transfer back to Earth are to retain a healthy occupation and standard always. Always perform redundancy checks for any engineering process. Always promote a fast-paced creative thinking and problem-solving environment. The only, and this is a very important one, the only acceptable grade of engineering is excellence. This is true on Mars because any engineering failure might result in mission failure and loss of life. So engineering tasks are not to be taken lightly on Mars, and they should not be taken lightly on Earth, okay? Another guideline is to drive towards teamwork and collaboration. Always, a healthy lifestyle promotes a healthy mindset. And last but not least, any obstacle you face in life is surpassed with perseverance and good effort. And this is certainly something that astronauts will learn on Mars. Any obstacle they face there will be surpassed with perseverance and good effort, and obviously good engineering. Now, impacts to sustainability development goals. I did not highlight them here, but the goals that are directly impacted in a good way from the Engineering Center are the number 10, the 9, the 3, the 4th, the 11th of the Sustainable Development Goals. Now, key insights to this is that no sustainability goals are compromised. So the Engineering Center does not invalidate or violate any of the 17 engineering goals. All key sustainable systems are present in the infrastructure to be able to make the Engineering Center completely sustainable. And I want to add a parenthesis and a little correction to this statement. The Engineering Center does not count with its own power source. So the only lack of sustainability is in power. Engineering Center is completely dependent of the power station or the power center of the overall station. And lastly, the Engineering Center, and that's the comment I wanted to correct. It's truly and theoretically not completely sustainable if we are to depend from power from the power station. So overall, that is my presentation. These are the references, mostly NASA based, and this is my personal contact and social media. Thank you, Dr. Resende, Aina, for bearing with me through this presentation, and thank you for everyone on YouTube that'll have a watch. Have a great day.